Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problems tab. And if you scroll down, there is search bar. Search here, reverse linked list and hit enter. So there is a problem number 206 and it comes under the easy category. So let's open it. So it is mentioned given the head of a linked list. So this head is given of a linked list. Reverse the list and return the reversed list. So we need to just reverse the list. Basically, 1, 2, 3, 4, 5 is list is given. So we need to make it like 5, 4, 3, 2, 1. Similarly, 1, 2 is given. We need to make it 2, 1. If it's empty, then we need to return it's empty. Okay. So how we are going to do this? We know like in the linked list, if we have to traverse, because this is a single linked list, this is not a double linked list. If we have to traverse, we can traverse in a single go, right? So from if we travel, if we start from one, because we can start only from the head, right? So head is on node number one, and then we can go to the head dot next, that is in the node number two. Then we can't go back, right? Then we can go to the node number three, then we can go to the node number four, then we can go to the node number five, right? So what we can do is, as soon as we travel, we can just reverse these pointers, the middle pointers. Basically, right now, 2 is pointing to 3. So what we have to make it, 2 is pointing to 1. So right now, 1 is pointing to 2. We need to make 1 is pointing to null. So we need to point 3 to 2, 4 to 3, and 5 to 4. So let's see in some diagram. So just figure out this loop, only this one. This loop. So we have given this loop 1, 2, 3, 4, 5. So 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, 4 is pointing to 5, and 5 is pointing to null. All right. And what we want. So what we want now just see the last one. So earlier we see the first one, now see the last one. So what we want, 1 minute, what is happening? Um, Yeah. So if we see the last one, what we have like done is, so 1, 2, 3, 4, 5 will remain same. We just reverse the pointers. So we are just reversing these pointers. So now 2 is pointing to 1, 3 is pointing to 2, 4 is pointing to 3, like 5 is pointing to 4. Now we have to like see how we can do that. 1 minute, like what happened? Let me adjust this 1 minute. Okay, so what we have to do is, uh, like we will take just this list example and try to see how we can approach this problem. So this list is given 1, 2, 3, 4, 5. So what we have to do is the current pointer, whatever is the head, we have to point. So let's write the first the base case. Like, if there is only one node, then we don't need to reverse. And if there is no node, if the linked list empty, then also we don't need to do anything. So let's try that thing first. So if head is none, head is none means this scenario. There is nothing given in the linked list. If head is none or head dot next is none, which means only one node is given. If there is a one node, then we don't need to reverse. Then we are going to return head only. So this two scenario has been covered. So let's now see the other scenarios in which we have to given more than two elements, two or more than two elements. So as an example, 1, 2, 3, 4, 5. So what we have to do, so whatever the current element, like right now the head is pointing to the head dot next. So if we have to reverse it, what we have to do, we have to point this head element to the none. So basically we have to do head. If we just nor if I just normally write head dot next is equal to none. Let's suppose if I am writing head dot next is equal to none, because the same thing I have to do. Right now head is this, and I have to do head dot next is none. Okay, so this part is done. So this part is done. But what about the rest of the thing? How now I can go to the node number two? Because I already remove this pointer. I already removed this pointer, right? So how I can go to the node 2? So that is the like question. So before like moving the head dot next to the none, we have to store the next pointer somewhere. So what we can do is we can so now we have to store the next pointer and we need the current pointer. So by this scenario, because if we just point this to none, then we are like miss the next pointers, because how we are going to track, because already we remove the next pointer. So how we are going to track? So it means we need the two pointers. So we need the previous pointer and we need the current pointer, right? So previous pointer is equal to head. So let's remove this. So previous pointer will point to the first node, because for if there is no node we have covered. If there is a two node, if there is a single node we have covered. Now the case is if there are two nodes or two or more nodes. So if there are two or more nodes, so the first node will be the previous, the next node will be the current. So first node will be the previous, the next node will be the current. So current is equal to head dot next, because we know what we have to do is we have to make previous element to none. Previous dot next should be none. That's why we have to store the next node. Because if we can't store the next node, then we can't traverse 2, 3, 4, 5. That the same thing which we did now. So we store both the pointer. Previous is equal to head, current is equal to head dot next. Because we have to make previous dot next is equal to none. That's why before making the previous dot next is equal to none, we have stored this pointer current is equal to head dot next. So this part is done. And why we do this previous dot next is equal to none? Because the last node will always point to the like none. Because if you see the single linked list, the last node will always point to the none. And when it's going to reverse, so the last node will be the one. So one will always going to point to the none where I put the cross mark. Okay, so now previous is this, current is this. So what next? What we have to do? So we have to point this current pointer, current dot next. So right now current dot next is this three. What we have to do? Current dot next should point to the previous. So to previous. So current dot next should point to the previous. Basically, two should point to the one. So what we have to do is what we have to write. We have to write current dot next should point to the previous. We have to write this. All right. We have to write current dot next should point to the previous. But if we write current dot next point to the previous, then one and two is fine. But what about the three? Because we are removing this pointer. So if this pointer is removed, we are going to miss. Then how we are going to track 3, 4, 5? All right. So we have to store before assigning current pointer to the previous element. We have to store the current dot next pointer somewhere. So that's why let's store the current dot next. So before assigning the previous element, we have to store the next pointer, current dot next. All right. So now current dot next is this like this three. So now we can point uh, 2 to 1. So current dot next to previous, because we already store this pointer 3. So because we already store this pointer current dot next is equal to in some variable, and then we are going to point current dot next is equal to previous. All right, current current dot next is equal to previous. So now our current is this. So we have to make this as a previous. So how we are going to make this as a previous? So what we are going to do is uh, previous element is equal to the current element, because whatever the previous element, so we are making the like p like p pointer is like the current node only. So let me explain again. So 1, 2, 3, 4, 5 is there. What we have to do is we have to put we have to the head node should point to the none. So if we have to point to none, we are going to break this loop. And if we are going to break this loop, break this pointer, then we can't track this. That's why we have to store the next pointer. So that's why we took the a two pointer in starting, previous and the current. And as soon as we took the two pointers, then we have to put previous dot next is equal to none. So previous dot next is equal to none. That is fine, because in rest of the scenario, previous dot next is not none. Previous dot next is some element, like previous dot next is 2, previous dot next is 3, previous dot next is 4. Right, there is a some element, but for the first node, previous dot next is none. That's why we put previous dot next is not like outside, as the first statement only. Then for everything, like then we can run a loop kind of thing, and we have to run the loop until the current is not none. Then we can run a loop while current. Then we can run a loop while current. All right. So this element is done because previous element can be none. Then we have to run a loop. So now we have to point current. So current is this, previous is, now we have to point current dot next to the previous. We have write current dot next to it equal to the previous, which is fine. But if we write current dot next is equal to previous without storing the next element, then we are how we can track 3, 4, 5. That's why before assigning current dot next is equal to previous, what I did is current dot next I put in the some next one. So current dot next is equal to this one. So exactly this is the current element, and now this is the previous element. So I make current is equal to previous, and the whatever the next which I stored, I can make it as a current. So our current is equal to next. So that's it, and we can return the previous. So let's run it. So all the three cases has been accepted. So let's try to submit it. So our solution has been accepted, and we beat 87%, and we are taking very less memory, and we beat 89% of the people in the memory as well. So you can like okay, let's traverse one more time. So previous is this, current is this. Now we have to point current dot next is equal to previous. So in the code, current dot next is equal to previous. But before assigning this element, we have to store the next element. So we are assigning this element here in the next here. So we have stored this one. So now we have assigned this. So if we have assigned this, now we can make this as a previous element. So we are making this as a previous element. So previous element is the current one, because previous element is the current one, and whatever the store which we already stored, that is the current element now. So whatever we stored, that is the current element now. Then we can proceed further. So now we have to do current dot next to the previous. But before doing the current dot next to the previous, we have to store this element. So we have to do current dot next to the previous. But before that, we have to store somewhere the next element. So we have stored the somewhere next element in the next node. Now 3 will become previous and the fourth will become current. Now we have to again point 4 to 3. So current dot next is equal to previous. Before assigning current dot next to the previous, we have to store this pointer. So that's why we store this pointer current dot next into some variable. Now previous is this is equal to current dot this. Now we have to do is current dot next is equal to previous. But before doing this, we have to store the next pointer into the next node. So we have stored the current dot next into some pointer dot next node. All right, we have stored that. Along with that, current dot next is equal to previous. So current dot next is equal to previous. So now it will become, so current will become previous, and current will become next. So the current is none. So this node will become previous. So that's why we are returning previous. We can't return the current because current will become the none. So that's why we are returning the previous. So we have like done the solution. But if you scroll down, it is mentioned a linked list can be reversed either iteratively. Iteratively means using loop. So we have done using loop, or recursively. Could you please implement both? They have expected us to implement both. So we have implemented iteratively. Fine. Now we have to implement the recursively. So like there is a, like we can also implement in the recursive fashion. Recursive, like maybe like in some other video we can do that. So in the recursive, like what we can do is, so let's suppose 1, 2, 3, 4, 5 is a node. What we have to do is, we will we will like we will create some function. All right, let's put the reverse list, and we will pass the whole list into the reverse list function. Uh, Recursive is we are calling the same function again and again and again and again. So what we have to do, so we are not going to write the code. I am just like a little bit explaining. what is basically recursion. So in the recursion, what we have to do, so let's suppose 1 2 3 4 5 is this node. So what we have to do is we have to pass 2 3 4 5 into the function, and I will tell the function make 2 3 4 5 reverse, and I will attach one to that list. Then 2 3 4 5 is a list, then I will pass 3 4 5 into, then 2 3 4 5 will said. So 2 3 4 5 is a different list. Now 2 3 4 5 will said I am giving 3 4 5 is a list, kindly make it reverse so that I can attach 2. Then 3 4 5 will said kindly make 4 and 5 reverse so that I can attach 3. That is, you should do the function, you should reverse the list, I will attach myself, that's it. Then 4 and 5 will said you should reverse it, I will attach myself. Then 5, then only 5. So 5 will go to the reverse list and it will set reverse itself. But 5 is a single node, how it going to reverse? So that's why you have to write some base case. So if head is none or head dot next is none, then we have to return the head. So one is the base case. So in the recursion, we have to write one base case. We have to write the function which is going to call again and again and again. And then we have to write a little bit 2 3 line logic. But there is a problem in the recursion is recursion consumes a lot of memory. So if you write the recursion solution, right now we are beating 89% of the people in the memory. But if you implement using the recursion, you will see you are beating only 15% or 16% of the people in terms of memory. Okay, so but anyhow, like we have implemented using the iterative or recursively. So any approach, so iterative approach we did. So we are not going to implement the both approach. So that is like perfectly fine. So that's it. That's the end of the video. And thank you. You can also try this question.